Hello, so this is lesson 1 of Java Beginner. So in Java, this is Eclipse. Hopefully you have this installed or some other IDE or Replit or something online. Okay, so this is Java. This is what it looks like. We're going to be writing our code all in this section right here, in between the public static void main string args thing, curly bracket and this curly bracket. You don't need to worry about what this means right now. Just know that all of your code is essentially going to be inside of this little space. And don't worry about this public class thing as well. Just make sure that you're writing your code in between the curly braces. Okay, so first thing we're going to talk about is the output commands. So to output something, there it is. So let's run this program and see if this works. And there you go. So it should appear in the terminal or console. Right now it just says Alden because I put Alden here in a print statement. So that's how you output something in Java. It's the first thing you need to know. Let's try outputting below a shape. Okay, so we have a print statement. Let's output some figure. Right? It doesn't have to be anything. %00. And let's have one more print statement. So let's give it these carets, these angle brackets. So I'm not sure if that's what it's called, but let's try this out. And there we go. Okay, so we've just printed out my name first of all, and also this weird shape using just print statements. So already with Java, we've accomplished this much. Yeah, just by using system.out.println. Okay, so that's how you print something out. So now we're going to move on to variables. So a variable, I'm sure you've heard of it before, is a storage. Like in math or something, find x or something. Variable is just a storage in Java. Okay. So let's create one. Let's create variable a and store 3 inside of it. Okay. So to create a variable in Java, it's just type name equals value. So right now the type is going to be int. I'm going to explain that later. Name is a and the value is 3. So there you go. We've just created a value. We've just created a variable. So if we print this, if we run this, nothing happens, obviously, because we've created a variable, but we haven't done anything with it, right? We haven't printed it out. There's nothing for the console to be showing, so we have to actually do something with it. Before we go to that, let's create some other variables just to show. So let's create variable b and store 11. So we can create multiple variables. Int b equals 11. Alright, so there you go. We've created 2 variables. But we can actually create an infinite amount of variables within reasonable limits. So int c equals 13, int d equals 15. And now let's actually do something. So output b times c minus a divided by d, or d divided by a. So if we use this system out print thing, let's just do b times c minus d divided by a. Okay, and we get 138. So that's perfect. We can do math with Java as well. So what's really important is that we're using these variables actually. B, we're harnessing the value of b using just the name of the variable. So we can actually use variables. That's important. Okay, let's talk about integer data types. So the first data type we're going to learn is, first of all, we learn about int, right? By the way, these are called comments, by the way. If you see a double slash in Java, you know it's a comment, a double forward slash. So this is a comment, and clearly if you print it, if you run, nothing happens because it's just a comment. It doesn't do anything to the code. It's grayed out. The computer doesn't see it, essentially. So you use comments to understand your code, to give you some like guiders, like, so when you look back you actually understand what your code is about instead of just like being totally confused. Comments allow you to just write English and write stuff without the computer actually thinking it's actual code. So this a comment. If we remove slashes, you can see that the computer is giving us an error, right? Or Eclipse is giving us an error because this doesn't make sense, right? This is not actual Java. So you have to add 2 forward slashes, and that's a comment. Computer no longer recognizes it. Okay, so we learned about int, right? But there's many others. So first of all, there's byte. So if you heard about binary computers, any sort of that, like, you probably already know this, right? A byte has 8 bits, and this is what I mean. Don't mind this, I was just experimenting with this drawing tool, which is really cool. A bit is a 0 or 1, right? If you ever heard about binary, you already know this, right? This is very simple. Computers use binary, but basically a bit can either be 0 or 1, and they can only be 2 choices. So a byte has 8 bits. A byte, has 8 bits. So you can imagine this as a line of these bits, and it's like this. And then it can be 0, 1, 1, 1, 1, 0, 0, 1. Something like that. And there's actually 2 to the power of 8 possible combinations of these zeros and ones. And that's how you store numbers, right? This is how you store integers. By the way, bytes, you've heard of megabytes, gigabytes, terabytes. That's what those refer to. But right now we're just talking about bytes. So a byte has 2 to the 8 combinations. And this makes sense, right? If you look at just one of these bits, it only has 1 or 0. So there's 2 combinations. If you add another one, say there's another 0, 1. This 0 can pair up with the 1 and pair up with this, and then 1 can pair up with these. So now you have 4 different combinations, and I can list them. So there's also 0, 0, and 1, 1. So now there's 2 to the power of 2 combinations for just 2 bits. If you add another one, you're going to be adding twice the amount, right? Because you're essentially duplicating the amount of combinations with each bit that you add, meaning that now you have 2 to the power of 3 combinations. So with 3 bits you have 2 to the power of 3. Obviously with 4 you have 2 to the power of 4. So it makes sense intuitively that if you have 8 bits, you have 2 to the power of 8 combinations. Yeah, so you can use bits to store values, and bytes are just 8 bits. So again, 8 bits stores 2 to the power of 8 values, which means that you actually are only storing from negative 2 to the power of 7 to which is, by the way, it's a negative 128 to 2 to the power of 8, which is 2 to the power of 8 minus 1, 7 minus 1, which is 127. So really you're storing from negative 128 to 127. That's really all you can store inside of a byte. The next one is called short, and this one has 16 bits, which means that you can store 2 to the power of 16 values inside of it. And by the way, if you hear any like machinery, like what's happening outside right now, just don't mind it. That's just what's happening. Negative 2 to the power of 15, which I don't know. And 2 to the power of 15 minus 1. And the reason why it's minus 1, if it was negative 128 to 128, for example, you have to also consider that you one combination is with a 0. So you have 256 combinations, but one of them has to be used for zeros. And so either the negative side or the positive side has to accommodate for that. So you can really only store from 127 to negative 128, not 128 to negative 128. Because you have 128 on this side, 128 on this side, and you also have a 0. So you have to, accommodate for that. Okay, and then we have int, which we've been using. So this one has 32 bits, and it can store 2 to the 32 values. And this is equivalent to negative 2 to the power of 31 values, 2 to the power of 31 minus 1. So you can store numbers from those ranges. And finally, there's long, so short and long, which has 64 bits, and can store 2 to the 64 combinations, which is 2 to the power of 63 to 2 to the power of 63 minus 1. Now, we usually just use int for these things. Int can store like what is 2 to the power of 31, right? It's about 2 billion. So usually you don't really need to use long, which, like, if you can imagine, 32 twos is around 2 billion, right? 2,700,000,000 700 million or something. You have 32 twos, and then you add another 32 twos, so that's insane number. So you use long for really long numbers, for really big numbers. Usually int is enough, but you don't really use byte or short that often. You can just use int. Like, your computer won't run out of memory with that. Usually for every question you can just use int, but in some cases you can use byte or short. So let's try using these. Byte, create variable m byte, type is byte, store 155, and then create another variable, and type is short, store, let's say 66. So let's try this. It's the same as before. Okay, type name value, right? Type is bytes, name, it's going to be m, equals 155, semicolon. And then next one, short, and equals 66. Okay, obviously if you run it, same as before. Actually, what's going on? There's an error. Exception in thread main, Java blah blah blah, unresolved compilation problem. So type mismatch cannot convert from int to byte. Okay, what does this mean, right? You can see we're getting an error here. So Eclipse is telling me I'm getting an error at this 155. So what's going on here? Why can't I set this byte to 155? So what's actually happening is you can't store this big of a number in byte, actually. If you look back, byte can only store numbers from negative 128 to 127. So let's try reducing this. And there you go, it works. As soon as you get to 128, it doesn't work anymore. Java does not accept bytes that store above 2 to the power of 8 values. That doesn't make sense. So this is the restrictions that you need to follow. So if you do negative 128, that works, but as soon as you cross that line, it doesn't work anymore. If you store any other value though, 69, 30, 0. There's no negative 0. What? I mean, I guess there is. But alright. I'll just say 55. Okay. And now we've created two variables like that. So that's the introduction to Java. We've only learned about integer data types so far, but we'll talk about decimal values, we'll talk about strings, which are text, and characters, and booleans, which are true or false values. So we're going to go over that in another time. Bye-bye.